Bismillahirrahmanirrahim. This is our 19th lecture. So we are going to study some game theory, basically from sections 1 and 2 of my own paper. And the basic lesson is that real human behavior is very different from what economic theory says human behavior is. So we will illustrate this in some very simple games. So here's what the Quran has to say, that the shaitan deceives us, and the greatest jihad is to battle against our own self. Basically, the human heart is a battleground between good and evil. So human motivation, human behavior is very complex, because at the same time you have the impulse to do good and also the impulse to do evil. So who wins? We don't know. That's actually the main purpose of life, to try to make the good win. But this is never certain. You cannot be sure of this. So that's why it's not easy to give any simple account of human behavior. So there is Homo economicus, which is always bad behaving. And then there's Homo Islamicus, which always behaves very well, but neither of them describe the reality. So we start by discussing the normative positive distinction, which is very commonly made in economic theory. A theory is normative if it describes something which is ideal, something which is desirable, but does not actually describe what is the reality on the ground. As opposed to this, positive is supposed to be something which is descriptive. So now, according to standard economic textbooks, they tell you that economic theory is a positive theory. It tells you what is the reality on the ground. It is not a normative theory. So if you say that, for example, that supply and demand is a positive theory, then in order to prove this, then you have to show that it matches with the real world data. But this is not done because it's not true. Similarly, utility theory is supposed to be a positive theory. It's supposed to describe human behavior. But it simply does not. There is lots of evidence. Basically, that's what behavioral economics is about. They took these assumptions about human behavior and then they tried to match them to real human behavior, and they found that there was no match. By now, this has been extensively tested by many different people in many different fields, and the universal conclusion is that economic theory is not a descriptive theory. We have seen some examples of this. Ultimatum Game, the economic theory describes exactly what human behavior should be. It says that the offerer should offer exactly should accept exactly 1 out of 10, and the responder should accept. And neither of these things is true. Neither of these things happen, and neither of these things is expected to happen. So economic theory confidently makes predictions about human behavior based on maximization, and these are seriously wrong. So now the question is, what kind of a theory is economic theory if it's not a positive theory? So people have come to the conclusion that it is a normative theory. It says that this is what rational behavior should be like, and it does not actually describe. So then it says this is an ideal type of behavior. So then there is a question of what are the grounds on which this idealization is based. So the economic theory, all of it, is founded on the idea that human behavior is that of Homo economicus. And Homo economicus is cold, calculating, and callous. I have already, I think, discussed this, that he has no emotions. He always finds the advantage to the last penny, and he's callous, meaning disregards, he has no concern for other people. So these are the three properties that Homo economicus has, and none of these is true of any human being, not not just Muslims. So now the question is this a good normative theory? Is this how we should behave? And the answer to this is also no. This kind of behavior is very harmful to our souls, it's very harmful to our happiness, it's very harmful to our material advantage, because actually if you are unconcerned about others, then they will not be concerned about you, and basically we all need society to survive. So if I show that I don't care anything about anybody else, then they will also not care about me. And since normally we are all dependent on each other, so this will be a very harmful strategy for me, for my own simple material, earthly, worldly advantages. So it's just not a sensible theory by any means. So actually economic theory, as I've said, is already deceptive theory. It says it's positive when it's not. In fact, it is an obstacle and a handicap in understanding human behavior, because it says confidently this is how humans behave, and actually it is not how humans behave. So there are many situations, some of which we will go through today, where everybody understands human behavior much better than economists do. For example, the Ultimatum Game is an example. Nobody has any difficulty understanding why Ultimatum Game is of any importance. Yani, if somebody ran this game and said, okay, so what? I mean, what do we learn by this? Everybody knows that people would like to share to some extent. But the economist, it's a catastrophe, it's an earthquake, it's a revolution. Because basically the foundation of economics says that all people prefer more money to less money. And even Stigler said that, well, yes, people say things about fairness and justice, but when it comes down to the reality, people will take more money over all of these abstract concepts. Now the Ultimatum Game shows that Stigler is wrong, that people do care about fairness and justice and equity, and they are willing to give up money to obey these values. So it's not that. So economists think that money is everything, but reality is that money is not everything. So for economists, there is a huge literature on why do people cooperate, because the Homo economicus cannot cooperate. So to other people, this is not a question. Obviously, we cooperate for any. And this is not something we need to ask, that why do people cooperate? Similarly, why are people generous? Well, this is built into us. Why do people sacrifice for each other? Again, this is something which is a great puzzle for economists and is easy to understand for normal human beings. So, in context of the Ultimatum Game, people are concerned about fairness. People want to act fairly. People would like others to act fairly. People would like to be viewed as being fair. So even if they are not so fair, they are concerned about their image and they want to make other people think that they are acting fairly. So all of these factors exert an important influence on behavior, much more than just maximization of utility or maximization of money. So these are the things we've already seen. So this is just sort of a review. So because these results were so surprising to economists, they refused to accept them. Because basically, according to the economic theory, if one choice gives you more money and the other choice gives you less money, you will always prefer the choice which gives you more money. Now people don't behave like this in Ultimatum Game. So the economists objected to these results, and they had three major objections. They said, the lab conditions are artificial, people don't really, and this is not like what happens in the real world. And then there are that you are playing for small stakes, $1, $2, and people don't take this seriously. And again, people don't have experience in this game. They don't understand the full consequences of what they will do. So the experimentalists, the behavioralists, worked on overcoming all of these objections. They did field experiments where they did the experiment in situations which were very much closer to the real world, outside of labs, in real life, like some of the situations are described in Colin Camerer's book, where you have real world games where a photographer is taking photographs and trying to sell them to people at very high prices, and so on. So the same type of result occurs in the real world. And then they played these games for very high stakes, for 1 month's salary in I think Czechoslovakia, and similarly very high sums of money in Indonesia after the East Asian crisis, when the value of the rupiah was very low. And again, they got the same results. And they played this game with lots of experience, with people playing this lots and lots of times, so that people understood what the game was. And again, all the same results came up. So ultimately, the economists were reluctantly forced to accept these results. Colin Camerer, in his book on behavioral experimental economics, writes that if I only had $1 for every time an economist said that if we just make the stakes high enough, then the results will converge to rational behavior, I would be a billionaire. But I would have a private jet on standby all the time. But so the economists just don't believe these results, but these results are nonetheless valid. So today I will discuss the game which has no name, but it was introduced by Beard and Beil, so we'll call it the B&B game. And this game is described on the screen. So at the first move, Adam is the player 1, and he gets to choose between left and right. The right move is the outside secure option. It means that it gives him a certain payoff. The other player doesn't get to do anything. It's like the dictator game. So in that case, he gets $7 as the outcome. And the other player gets some amount $B, and we will discuss what this B can be and what impact it has later. For the moment, according to standard game theory, Adam doesn't care what B is, and Ben doesn't have any option about choosing, so the B doesn't matter. So Adam can basically drop out of the game and take $7 instead of playing the game. The other option is that he can choose to go left, in which case Ben will have the choice of doing something. So he has two choices. One of them is harmful to Adam. The first one, the left choice, L, gives Adam 0 and gives Ben $3. Again, X we will vary later. For the moment, think of it as 0. The right choice gives Adam $10 and Ben $5. So according to the standard theory of backward induction, which is your Fiona Carmichael text, Ben will choose R, and so he will get $5 because it's better than $3 which he gets on L, and so Adam will get 10. So now once we do backward induction, we find that left play by Adam will give him $10, right play will give him $7, so he should choose left. So this is the standard game theoretic analysis of this game. Now let us see what happens when we do a real analysis, real world analysis. So there are 4 predictions. Let's list these 4 predictions. So we start by the backward induction, the bottom move. So looks first at Ben, because so Ben, if he gets the chance to play the game, he will choose R, because that gives him $5, and he will not choose L because that gives him 3 plus X. As long as X is small, he will prefer the higher payoff. So that's one prediction. The second prediction is that P1 can rely on the rationality of P2. This is important because it's not just that P1 is rational. P1 has to assume that the other guy is also rational and he is maximizer. So can we rely on the rationality of others? Can we rely on others to make the best choice? Obviously, for example, if the other guy is a child and doesn't know how to calculate, maybe we would not rely on this. So that's the second assumption. The third assumption, so in order to get the solution, we have to assume that P1 can rely on the rationality of P2. This is an assumption about P1, not about P2. So once the third assumption is that, okay, if you can rely on the rationality, then P2 will play R, and therefore you will get $10 if you play L. So you will prefer to play L. So these are 3 predictions. And then the fourth prediction is that the value of $B, which is what P2 gets on the outside secure option for player 1, it does not matter. Whether or not the player 1 plays P1, what the value of P1 will not have any impact on how the game is played. So that is what the textbook says. If you read Fiona Carmichael and analyze the game, this is what you will get as a result. Now the anti-text says that all 4 of these predictions are seriously wrong. So let's look at this. So can we rely on Ben to choose R? What do you think?
If X is greater than X value is greater than 5,
It depends on the value of X. For example,
if it is equal to 3 or greater than 3, he will choose left.
oh no, we assume that 3 plus X is less than 5. So strictly smaller. According to economic theory, because of the calculating assumption, even if X is $1.99, so that Ben is getting $4.99 on option L, and is getting $5 on option R, Ben will choose R because it is the maximizing option. So what do you think in reality will happen if X is $1.95? So he gets $4.95 in L and $5, 5 cents more in R. So what will happen in reality? What? Rationality, you see, now we would like to take back this word rationality from the economists. So let us say that this is maximizing behavior or calculating behavior, that you always are thinking about the last penny, which is not true of human beings. So what will really happen here?
Sir, it depends on Adam and Ben relation.
No, let's suppose that they are strangers. They don't know anything about each other. Huh? If Ben is thinking about Adam, then he will choose R because Adam is getting a bigger amount. Alright, let's look at just the experimental results. Here is the experimental results, that if they played this with $4.75, so there was a 25-cent difference. So in reality, about 85% of the players in the second position, this was a real game with real money and real players and real human beings, 85% acted correctly, that is, they chose R. But 15%, for whatever reason, they chose the other option. So, the point is that people are not that much calculating. They ignore small differences because actually it's a very sensible thing. This is called a heuristic, because calculation involves a lot of costs. And so if we are in a hurry, we just quickly say, okay, this is good enough. This is called satisficing behavior. And there's lots of evidence. This is what Herbert Simon did, and that's what he won the Nobel Prize for, that people don't maximize, they satisfy. Exact maximization does not hold. This is a very important finding about human behavior, because it turns out that there is a huge difference between exact maximization and approximate maximization. Because it turns out that in many problems, the maximization problem is very, the maxima is very shallow. I mean, you have a very broad surface, and the exact maxima is unique point, but if you say approximate, then there is a huge number of different options which will give you approximately the maximum. So if you allow for approximate maximum, then you can't say anything about what behavior will be like. If you say exact maximum, then you have only one. So, and there is a lot of literature on how, if we just, there is a literature on menu costs which says that if restaurants basically look at the restaurants, the marginal costs fluctuate every day. If they buy tomatoes and they buy meat and everything, every day these things are fluctuating. So how come their prices remain the same every day? This doesn't seem like profit maximization behavior. So the answer, one answer which is given, which is not the correct answer, but it's a possible answer, that they have to print the menu every time differently, and that costs, and that small amount of friction cost will prevent them from doing maximization. So instead of maximization, they do approximate maximization. Of course, you have all seen restaurants which have sort of write-in menus where you use the pen to write. So if the prices fluctuate. But anyway, the point is that approximate maximization has serious consequences for economic theory. So now, does the player 1 trust the other player to maximize? This is another interesting experimental finding. So when the difference is large, we can trust the other person to recognize that this is in his favor. So like if it is $3 and $5, this is a big difference. And when this was the case, then the first player did rely on the other person to choose his best interest, and the 84% of the first players played the left strategy, counting on the other player to choose R so that they would get the higher payoff. But when the difference was small, so I think it is 10 cents, then only 48% of the first players took the chance. So I'm describing actual human behavior. So if I said that it's $4.75 versus $5, and now I put you into the real game, how would you behave? Well, people say that, the other guy might choose $4.75, and then I will get zero instead of $10, which I am hoping for. So might as well take $7 cash and not take the chance, right? So 52% of the people actually did this. They took $7 instead of relying on the other person to maximize. So again, this is a failure of economic theory. We cannot rely on, and we do not rely on other people to maximize their own benefits. So again, this is something that human beings know. According to standard game theory, the value of x does not matter as long as 3 plus x is less than 4. Conclusion of the game is exactly the same. But in real world, This is not true. Human beings know this also. Human beings know this. Game theorists do not know this. Because game theorists calculate according to backward induction and they get to the wrong conclusion. Human beings can understand what's happening better than economists, because economists are blinded by their theory. Now there is another option. Let's look at this game. Suppose that this B, this amount that I left unspecified, which doesn't matter, suppose that the game is exactly like this. It's 3 and 5 now. X is 0. So normally we would be able to rely on Ben to play R. But suppose now that B, the amount that he would get if I play the secure option is $15. Now what do you think will happen?
Ben will play because he couldn't get $15.
Yes, Ben will say that, well, if you are not going to give me my benefit, I'm not going to give you your benefit. So he will play. So in real world, in real life games, Adam, if he is playing this game, he will take the $7 option because he knows that the other player will not maximize. This is again against the concept of sub-game perfection, because you see, Ben will say that, look, if you play the right option, I'm going to punish you by playing L. So now the sub-game perfection idea says that, okay, ignore, this is not a credible threat. Go to the L, and once he is there, then he will realize that now that B is in the air. There is no more B, no more $15. So now I have to only choose between $5 and $3. So why not choose the more money? In that game, even if it's 5 and 0, we will expect Ben will play. He will say, okay, I give up my $5, but I want to see this guy punished. So, but if B is small, then we don't expect this to happen. So the thing is that human motivation, now according to the game theory analysis, the value of B is completely irrelevant. If B is 100 or B is minus 100, it doesn't make any difference. The game will play it exactly the same. But that is not true. P1, what should P1 do? Well, if P1 is a human being, he will play right and give Ben his $15. If he is an economist, he will play left, and he will be very surprised when Ben plays L. He say, why you did that? You're damaging yourself. So this is the analysis we've already done. Now this is a game which hasn't been discussed and in the text, and I haven't actually played it. Suppose that B is negative. Suppose that if I take my secure option 7, then B has to pay a penalty of $10. And now suppose I play left, and now suppose that the left choice is the advantageous one for Ben, the one that gives me 0. So now what will happen? Now this is again a situation of which is very different when played by human beings and when played by robots or Homo economicus. Now the Homo economicus has no problem. If suppose that Ben has $7 if he plays L, so X is actually $4 now. So now if Adam plays left, then Ben will play L, giving Adam 0 and taking 7 for himself. But is this what will happen in reality? Well, no, not if Ben is a human being. Then he will feel grateful to Adam for saving him for a penalty from $10, and he'll say, okay, I will return the favor and I will accept a lower payoff for myself and give you $10 because you also did something for me. So So this is called reciprocity. So what do we learn from behavioral game theory? Behavioral game theory basically is the study of all of these. The Thaler, who got the Nobel Prize recently, he is a behavioral game theorist. Basically, sometime in the 70s or maybe earlier, some psychologists found out that this is what economics are saying about how humans behave, and they also studied human behavior. So say, okay, let's study these economic theories to see if human beings actually behave like this. So then they started finding a lot of contradictions, and so this is what led to the development of behavioral economics, where we study the actual behavior instead of the axiomatic behavior. Now, economics is in a very strange situation currently, in that, you see, if there is a theory which predicts the real world behavior, then that should be the main theory. If there is a theory which says that here is a theorem about human beings, that they maximize utility, and this is the mathematical formula that they follow, and this formula human beings don't follow, then that will be a discarded theory. That people had used to have this theory in the olden days, but now it has been rejected, and now we have these new theories. But the current status in economic theory is exactly the opposite. The mainstream orthodox theory, which is currently being taught all over the world in universities, in Harvard and in Quaid-e-Azam University, is utility maximization. And behavioral economics is mentioned in a footnote sometimes, that actually when we test human behavior, you find that it is not exactly according to what we are teaching. But forget that, and let's continue our calculations. So this is very strange. Behavioral theory is a minority. It is battling for survival. Actually, what happened in the global financial crisis was that the economists said that these rational human beings cannot make big mistakes in calculating the real value of the stocks, and they cannot become very excited and start buying stocks just on the basis of emotions. So stock market prices behave rationally, and so there cannot be a bubble in the stock market. Eugene Fama, who is the inventor of this rational expectations hypothesis about stocks, got the Nobel Prize even after the collapse. And people asked him, well, what do you think of the bubble? He said, there is no bubble. So these people are just blind to reality. So the point I want to make is that behavioral game theorists are in the minority. If you read Colin Cameron, he's very defensive. And when they find a result that the behavior is directly opposed to utility maximization, is directly violates game theory, they don't say this, because they have to survive within the pool of economists. They say, well, there's some mismatch, but we can patch it up, we can fix it somehow or the other, because they need to be accepted. And that's what he says, that we are fighting for acceptance within the economics profession. So, behavioral game theory, the main findings of this is that generosity is universally observed. It is actually a human characteristic to be generous. It doesn't matter whether people are Muslims or Christians or atheists or Buddhists. Generosity is built into the heart of the human being. Furthermore, and this is what I mentioned last time, over the past 3 decades or so, not long ago, there has been a gradual realization that this idea that this is a cutthroat jungle and survival of the fittest means that you have to ruthlessly maximize, and you have to look only for your own advantage, and those people who look only for their own advantage, they will survive. This is wrong. Evolutionary biology does not teach the lesson, contrary to what was believed earlier, that only those individuals will survive who ruthlessly maximize. If somebody is sloppy, he doesn't calculate the exact maximum, he will be driven out of business. This is what the economists think, that if the firm, instead of being very sharp and calculating and finding the last ounce of benefit. If it says, if it's just relaxed and lazy and says, okay, as long as I'm getting enough profits to run the business, I'm fine, I don't need to maximize, that's satisfying behavior. These firms will be driven out of business by the efficient maximizing firms. This is not true. The cooperative behavior leads to better survival in many different situations than the selfish behavior, and we've already seen this. So, this idea that selfishness leads to efficiency, that maximization leads to efficiency, this is now being called into question, although not in the minds of the economists. So, this is one of the major insights from behavioral game theory, which can be used to write theses, because once you change the idea that human behavior is not maximizing, then you can rewrite all of economic theory. You can take any problem at all and you can say, okay, let's suppose that human beings behave according to what we observe in the real world instead of according to these mathematical formulas. Then what will happen? So this is a new question, and you can take any area of economic theory and you can write a thesis on it. It's all unexplored currently. Actually, I'm not saying what there is a lot of work going on, but basically what we say is that there is lots of low-hanging fruit. If you want to make an innovation in the mathematical theory of neoclassical economics, you have to study for 5 years to get to where the boundaries are. But in behavioral, things are right there, very close to where we are, because huge number of problems have been explored by economists using the wrong theory of human behavior, and just fixing the theory and taking a problem, you can find many problems which have not been explored. So you are at zero, and then you can add insights. Now the thing is, how do you do this? Because when you put in behavioral insights, then it becomes difficult to calculate what will happen. So there we have the computer, and that's what agent-based modeling and evolutionary economics is about, because the kinds of questions that we are asking are very difficult to actually calculate by hand like economists teach. So this is again another problem that economists were, economic theory was formulated in the pre-computer era. So now you see Alpha Chiang teaches you how to calculate by hand the answers to 5 or 6 different problems of calculus. Now if instead we say let's use the computer, see, this is like teaching students how to take 2 10-digit numbers and multiply them by hand. It's a very long and complicated process, and there you can make mistakes. Now we say, here, take the calculator and find the answer, then any child can do it. Similarly, the maximization problem that you're taught in Chiang, you can solve far more complex problems just by learning how to feed this problem to the computer. And the computer today, Excel and Mathematica and Maple and many other packages, will solve extremely complex problems without any difficulty. So you are being taught the wrong things in your mathematical economics courses, which we are trying to fix actually. We're trying to teach you, instead of solving the problem by yourself by hand with pencil and paper, we're trying to teach you how to set up a problem to feed to the computer and thereby learn 100 times more mathematics than what is being taught in the average program. So, if you want to do theses in behavioral economics, then you have to use the computer to model behaviors, and then you have to use the computer. You put in 1,000 consumers with 1,000 different types of behavior. No, it is impossible to calculate the answer to this by hand, but the computer can do it without any difficulty, and then you can see. And this is one of the major problems with economic theory, which has been discovered, that the dynamic stochastic general equilibrium model failed to predict the GFC, the global financial crisis, because it had only one representative agent. Because economists cannot handle heterogeneity. If you have 1,000 different agents with 1,000 different behaviors, then they cannot calculate it on pencil and paper. And that's all they know how to do. So, if you have only one agent, he cannot deceive himself. He cannot do fraud. So the DSG, the global financial crisis, occurred because some people were doing fraud to others, and this fraud concept cannot be encapsulated in a DSGE model. So if you have a correct heterogeneous model, and basically that's one of the weaknesses, that the conventional models cannot capture heterogeneity. The other weakness that is present is that the economic theory models cannot capture complexity. Complexity means that the sum of the behaviors of the individual is not the same as the group behavior. Why? Because interactions are important. So in economic theory, all over the place, the supply curve is the sum of the supply curve of the firms. The demand curve is the sum of the demand curves of the individual consumers. All of this is false and has been proven false, because the group behavior does not reduce to the firm behavior multiplied n times, because there are interactions between the firms. For every firm, the firm is small and it can ignore what's happening at the industry level, but the industry as a whole is not small. If every firm decides to increase its purchase of labor, the firm can think that there will be no impact on the wage because I'm a small firm. But if the industry as a whole, every firm is thinking like this, then every firm increases labor demand by epsilon. There will be a noticeable increase in labor, and therefore the wage will go up. So there are things like this which are serious difficulties with existing economic theory, and these are all very fundamental and basic, which means that the ground that is open for us to do research in is very large and very fruitful and very easy, because the problems that we need to solve, which have not been solved before, are just at the surface. Even the basic baby problems, 1 + 1 = 2, have not been solved because the economists are using wrong theories. So that's one thing. The second thing is that the preferences that we assume, the utilities, these are not universal invariants. They depend on social context, they can be manipulated by advertising, and furthermore, they depend on the cultural context. People generally do not seek to maximize wealth, but they seek to maximize social status. In societies where wealth is equal to social status, then maximizing wealth becomes a reasonable assumption. But in other societies where people believe in honor, dignity, knowledge, all of these things get value, then people will not be necessarily maximizing wealth, and they will be maximizing other things. So you have to look at the culture to decide how people will behave. Again, economics think that human behavior is universal and invariant. So the African and the European and the Indian and the Brazilian, they all have the same utility maximization, but this is not true. People behave differently in different cultures, and one of the things that has been used to show this is the Ultimatum Game. They played this in many different cultures and they got different results according to different cultures. The third contribution of behavioral game theory is that the framing assumptions are extremely important determinants of human behavior. So you see, because economists think that the money payoff is the only thing which matters, so then they reduce these complex game to these tree diagrams. But actually, the tree diagram does not capture the things that we need, because human behavior is motivated more than by money. So for example, if we were to, I was to bring in a peon here from outside, and I was to say, okay, let's play the Ultimatum Game. You get 100 rupees and you get to share with him. So people would behave differently because now the frame is different. It is not one student against another student. It's not between equal social classes or equal income classes. So this framing is different. And now if we had this game played in other contexts, if we described the game in different ways, that this is a photographer, he is selling this photograph of you, and it is worth nothing to him, he will throw it in the garbage, but he will sell it to you only for $5. So then you will have a different way of thinking about this, because your concern is not only with whether you are getting $5 or whether you are getting the photograph. You are also concerned with fairness. In fact, a very good example of this has been given by Thaler. He says that people go, somebody is very thirsty and he goes to, he's on the beach and it's sun is shining and it's very hot, and he goes to a small rundown shack, and they have, he is offering Coca-Cola, but he says that this will cost 100 rupees. So you say, no, you can't charge that much. The Coca-Cola is not worth that much. And even though it's freezing cold and he wants it. But right next to it is a fancy restaurant. And now, the thing is that he's going to take this and take it back to the beach to his friends. Yes, he has been commissioned to buy a case for his friends. So if the shack sells it at an outrageous price, the man will not buy. And this is reality. If he goes to the restaurant, fancy restaurant, and they sell it at a very high price, he will pay, even though he is not enjoying the benefits of the restaurant. That is, he will take the case of cold Coca-Cola bottle and he take it to the beach, and he will pay a large amount of money, much more than he thinks is fair, because he thinks it's not fair for the rundown shop to charge large prices which are out of line with its costs. So this again. So the context and other things matter in human decisions. And that's why the tree diagram doesn't actually tell us all the information that we need in order to play that game. In these games, things are clear because only on the basis of dollars. But normally, in real world games that we are playing, for example, there is a game of you play with your laborer, you hire somebody. So now there is the famous game of there are many games in which there is a large social context which is ignored by the game, and so the social context will matter. The game between husband and wife about whether they go shopping or whether they go to football, this will not be determined by the dollar payoffs. It will be determined by many other things. So again, there are thousands of experiments which have been done on prisoner's dilemma. Why? Because basically the theory predicts exactly the opposite of what really happens. So people have been trying to find out why. And so what are these lessons that we learn by running thousands of experiments? Well, most important is that human beings do not behave like Homo economicus. They do not maximize. They do not maximize locally. You see, this is the thing, that the game theory makes the wrong prediction. It says that you will maximize on this particular choice, on this particular game. No, human beings are living for a long time and they have to concern with their reputation, with their character, with the character of others. All of these things matter. And you're not going to change. So the economists try to take these things out of the picture. They say that, okay, there are two strangers, you can't see the other one, and your only reward is the money payoff. So it seems that all of these factors have been taken out. But actually we carry our characters with us into the game. So we can't say, okay, and now I'm going to put aside my real character and now I'm going to go for maximization of money in this game. No, if we are behaving in a cooperative and generous way throughout, then even in this little game where it doesn't matter and doesn't seem to be relevant, I will still behave cooperatively because this is my character. So human beings do not behave like Homo economics, even in the very, very simplified and artificial and strange experimental settings where there is no context. You don't know the other person and you will never see him again. Still you behave as if it's a real person. However, there are examples which people have done where they have set up a robot, a computer, and then people do behave differently because they realize that this is not a social situation. If I do him a favor, he will not respond by being grateful to me or by doing me a favor. Then people change their behavior if they know that they're playing against a machine which has been programmed to play according to certain rules. So that's one thing. The second thing is that according to economic theory, people play sub-game perfect strategies. So in an ultimatum game, if I give you a threat that if you give me less than 50%, I will reject your offer, you can ignore it and you can give me 10 rupees, and once I come to this sub-game where I have only the choice between 10 rupees and 0, I will come to my senses and I will choose the higher number. Now this is not how humans behave, and but human behavior is very uncertain. So cheap talk refers to commitment, that okay, in a prisoner's dilemma, let's agree to cooperate. So according to economic theory, this will make no difference, because the sub-game perfect equilibrium, once you get the chance to betray, you will do so. In fact, you will have even more incidents. Suppose we agree that okay, we are going to cooperate, so you know that I am going to cooperate, so now betrayal will give you even greater profit. So now you are pretty sure to betray, according to economic theory. But actually, it doesn't happen that way. The reverse happens. If people are allowed to talk, then they will come to an agreement and they will honor that agreement, contrary to what economists think. So people know how to trust each other, people know how to make commitments, and people know how to honor agreements. So they don't play sub-game perfect strategies. Another thing that happens in the prisoner's dilemma is that, so according to economists, just talking to us is cheap talk, because there's nothing to back it up. And so it should, according to economic theory, cheap talk does not alter the outcomes of the game. But in reality, cheap talk has a massive effect on outcomes of games. The third piece of knowledge that we get by studying real-world experiments is that the size of the temptation and the sucker payoff matters. That is, how much do you lose when you are betrayed, and how much do you gain if you betray the other? This makes a difference. Now, according to standard game theory, size doesn't matter. As long as there is a temptation, if it's slightly more, and as long as you get more. So again, this is the illustration of calculating. Whether it's 475 or 3, it doesn't make a difference. But in reality, in real world human behavior, if you are, if by betraying you'll get $1,000, and cooperation will give you only $50, then you are more likely to betray. And similarly, if betraying gives you a small payoff, then you are less likely to betray. And so these things matter. The actual amount matters. According to game theory, the actual amount doesn't matter, because the maximization is the same. And finally, game theory predicts that if you play an iterated prisoner's dilemma, if you play the prisoner 5 times or 10 times, as long as it's finite and fixed, you will always betray each other on every move. That's the economist strategy. That is the optimal strategy. That's Nash equilibrium. But in reality, this never happens. In one game, you do get betrayals, but in multiple games, human beings can figure out that it is better for both of us to cooperate, and they can usually do so. So this is routine. There is complications. I mean, there is some unraveling that occurs towards the end. I mean, towards the end, game theory considerations come into play, and people start betraying more than they do in the beginning. But so there's complicated reasons. All right. So then there is, similarly in behavioral economics, there are trust games and public goods. There is the Musharka game, in which we all contribute money into a pie, and then so this is a joint venture. We put money into a pool, then this pool is used for trading, and the trading earns some profit, and then this profit is distributed equally. Now, the way this game is set up is that this particular game is that the sharing is always equal. Everybody is an equal partner, but the contribution does not need to be equal. So everybody contributes however much they want. Then this becomes a common pool, and from this common pool, then what happens is that the way I'm going to describe an artificial game. We will assume that the money is doubled, and then it is returned to all the partners. Now this creates a prisoner's dilemma. I will explain this. So this is the game that you are going to play shortly. Everyone has 100 rupees, let's imagine. Now you are going to contribute from this to the pot. You can contribute any amount you like. You can put in 0 or you can put in 100. So let's just play a sample game. So the first round. So you have to decide how much you keep and how much you contribute. But don't decide right now, but let me explain what will happen. So suppose that everybody, so there are going to be 4 players in each game. That's just to simplify matters. Group yourselves into 4. Just sit with your 4 neighbors. Take 4 neighbors and sit together so that just arrange yourself into groups of 4. So now everybody contributes something, and now, so suppose I'm going to suppose that people decide to contribute half. Everybody puts in 50 rupees into the pot. So what happens? The pot is now 200 because there are 4 times 50. Now this is doubled. It becomes 400, and then it is returned equally to all. So everybody gets 100. So you end up with 150. You had 50 to begin with. You contributed 50, and you got 100 in return for that. So you end up with 150. So what is the optimal strategy? Well, the social optimal strategy is that you should all put in everything. So everybody puts in 100, it becomes 400, it becomes 800, everybody gets 200. However, if you look at the individual optimal strategy, it's different. Suppose that you think that everybody else is going to put in 100. Alright? So now you have the incentive to cheat. If you free ride, exactly. The other people will put in 300. This will be doubled. It will become 600. Then it will. Everybody else will get 150, dividing it 4 ways. So now you have your 100 of your own which you didn't put in, and 150 more. So you get 250. So you gain 50 rupees. On the other hand, the other people all lose 150 because so the social loss is larger because there's 3 losses of 50 and 1 gain of 50, but the private gain is higher. So this is often the case. This is the prisoner dilemma, that the private gain is high, but the social loss is also high. So basically the calculation is that if I contribute X dollars, it will get doubled and it will become 2X, but it will be divided 4 ways. So I will get back half of what I put in. Now as long as all people contribute, this is good for everybody. But if all people decide that I'm going to lose any money that I put in, half of it, so then if you do your individual calculations, then you should not put in anything in. So in a game played by 4 economists, nobody will put anything in. So what happens in the real world? Well, the general findings are for public goods that in games the cooperation starts high, but then it declines as people start to learn how to betray each other. Now, so economists, when they saw this, they said, look, this proves our theory. Economic theory is giving us the right result, and people learn how to play the maximizing strategy as they go on. But actually, the behavioralists say that this is not true. It is not due to learning. It is a complex social phenomena. And the argument for this is very interesting. They say, okay, we start in a round and we see that, okay, initially cooperation is high, then it goes down. Then we start a new round with the same players. We rearrange the players. So we find that cooperation again becomes very high. So if it was learning, then it would not be like this. Then people would learn that it doesn't pay to cooperate, so they wouldn't cooperate. But they do start out. So basically then the reason which seems to be matching to human behavior is that people start out by trusting others and saying that let's all cooperate, and they give everybody a chance. But people are very much disturbed by the failure of others to cooperate. So when they see that other people are not behaving nicely, then they also change their behavior. But at the end of the game, they haven't learned that doesn't pay to cooperate. They have learned that what they learn is that if somebody doesn't cooperate, then I will punish him. But you start a new game and you give people a fresh chance. That okay, let's try. So this is what really happens. There are very many mechanisms which you can use, like cheap talk, to achieve maximum cooperation. So I'm going to end the lecture here, and we are going to play this few rounds of this game. Now, we